I'd like to introduce onto stage, thank you, and he's already here, John Gossman, lead architect for Azure Functions at Microsoft.
Let's get this right. How many places can I click wrong to get this thing going? All right, arrow keys. Oh, we're not in the right place. Okay, let's start again. So my name is John Gossman, and I'm an architect in the Microsoft Azure team. The Azure team is basically responsible for the software that runs the Microsoft Worldwide Cloud, and we do a lot of different things, all the way from we write firmware for NICs and routers, up through the basic fabric for compute, networking, and storage that runs through all our data centers. And then we have the obvious services you'd expect for virtual machines and things like that, and then higher level PaaS services for SQL and NoSQL databases, machine learning, containers, and a lot of other different things. Now, my particular focus is on developer experiences. So that includes not only Microsoft APIs, tools, SDKs, languages, and things like that, making those things work with Azure, but also anything else that developers want to use. So DevOps tools like Chef, Docker, Kubernetes, Terraform, as well as Linux distributions and other SDKs and things like that. And so today, I'm here to talk to you and show you some of the things that we've been doing with serverless computing. But before I get started there, I think it's a good idea for us to reflect a little bit about where we are. I mean, literally us in this room, in this theater today at a serverless conference. Because we live in a time of incredible technological change. In fact, I like to say it's a world of science fiction. If you think about things that just a few years ago you would have thought was science fiction, we have these things right now. Self-driving cars are starting to become real. Certainly electric cars. People have drones. When I drive home on the freeway, I see drones buzz across the road above me. We have private companies that are doing space flight, and there's space tourists out there. And machine learning and artificial intelligence has become so commonplace that we really don't think anything of it to talk to our televisions and to expect them to respond and to use phones and other things and for them to recognize our faces and our fingerprints for login. And so I was thinking about this about a year ago, and I was talking to my mother, who is 88 years old, and I asked her, what was the biggest technological change that she had seen in her entire life? Indoor plumbing, she said. Very pragmatic woman. It wasn't what answer I was expecting, but okay. Anyway, but after that, she said the biggest change that she had seen was the smartphone. That she looked around at the people, her little old lady friends, her kids, their kids, etc., and saw this incredible change in just day-to-day behavior about people, how they communicate, how they navigate, how they shop, how they get information. You know, all you have to do is go into a restaurant and see a couple at a nice restaurant. Instead of talking to each other, they're all sitting there looking at their phones to realize, we really changed a lot of things. And, developers' lives have changed enormously, too. We're in one of these phases like the PC revolution or the web revolution or the smartphone revolution, where everything is changing so rapidly that it's actually very hard to keep up on all the pace of change that's going on. And so, if you're sitting here at a service conference, just remember that we're at the cutting edge of the cutting edge of the cutting edge, and maybe even a couple more cutting edges in there. But the bulk of developers are actually all over in the technological adoption curve. There are, a lot of people, of course, are running some sort of a legacy application that they're still having to maintain. Legacy, which is the other word for the stuff that works. And meanwhile, there's another part of that same group, or maybe it's the same developers, who've got something that is new and mainstream and actively being developed. And it was cutting edge 5 years ago, or 2 years ago, or last week. But they still have to, and that's still changing because maybe it's moving to the cloud, maybe they're using a new type of CI/CD or some other sort of process. But there's that. And then there's the true cutting edge stuff that's coming up where the ecosystem isn't completely developed out, like containers or serverless. And so in Azure, even though we're looking forward to serverless and containers and other worlds, we also are trying to hit developers wherever they are in that spectrum. So we have offerings for on-premise, for virtual machines in the cloud, IaaS, a wealth of PaaS services, and now serverless. The thing to remember is that Microsoft is a company by, for, and of developers. That we were founded by 2 developers, Bill Gates and Paul Allen, who were writing a developer product, Microsoft Basic. That our executive staff is still, the vast majority of them, have a developer background, all the way up to Satya. So if you ever try and demo some sort of a piece of technology to one of these guys, they're like asking deep technical questions and thinking about that experience. Now, our last CEO was not a developer. He is, however, famous for speaking very rapidly and repeatedly about how much he loved developers. So in that, you think about the DNA, I just know that Microsoft, we do think about developer experiences all the time, which is bringing us to serverless. It's interesting that I'm at a serverless conference, and yet I have to say, what is serverless? It's a sign of just how cutting edge we are, that all of you showed up at a conference where you're not actually sure maybe what the name is. But actually, we're further along than that. But at least I feel it's important to just lay a groundwork for how we see about it. So the first obvious thing of serverless is it's an abstraction of the server. So the programming model doesn't expose the server. You no longer have to manage the server, operate it, etc. The developer doesn't think about those things. But of course, there's been a wealth of PaaS systems over the last few years that have had that same thing. So the other part of serverless that really have to be captured is the fact that these serverless systems are event-driven and scale to the level of the events that are coming in. And furthermore, that you only get billed for the stuff that's actually happening. So if there's no traffic at all, there's no need to provision. There's nothing running, there's no need to pay for anything. And conversely, if the traffic suddenly picks up, the system scales instantly to that level of work, whatever it is, and you pay for no more and no less. So there's no need to over-provision, nor is there need, in the minimum case, to provision at all. And the advantages of this sort of thing, of course, is just developer productivity. Developers get to focus, instead of doing operations, instead of doing distributed systems magic to figure out how scaling and load balancing and things like that, is you just focus on your business logic and presumably get to market much faster. So let's get a little more concrete. In Azure, we have 2 primary serverless services. See, that's 6 times fast. One is Azure Functions. And Azure Functions is a developer-oriented experience. This is for people who want to code. As you might expect, you write functions. Things in the world, data sources and HTTP triggers, timers, etc., trigger events, and events are handled by functions. The other aspect of this is we have a thing called a binding. And binding is an abstraction of the data source itself, so that you don't have to write a bunch of boilerplate to read an item out of a database and another time to read something out of another data source. The bindings basically declaratively say what their input and output is and greatly simplify the programming model and get rid a lot of that boilerplate code. We'll talk more about bindings once we get into the demo. And then the other service we had is Azure Logic Apps. Azure Logic Apps is a non-coding experience. In Logic Apps, you use a visual designer to drag and drop to create workflows. Data, as it flows from node to node in this workflow, gets transformed or rerouted or triggers other things, like sending an email or dropping an entry into a database. And then, in order to pull in this ecosystem and all the other things, we have over 100 connectors to services such as Twitter and Facebook, Slack and GitHub, Office 365, but also Google Apps, so that you can orchestrate a whole set of different things from internal and external sources and flow them through these workflows. And one of those is functions, because sometimes you do need to write some code, and in this model you switch over to Azure Functions, you write your code, and you orchestrate that through Logic Apps. And we'll talk a lot more about Logic Apps later too. But of course, this is just the logic of your application. In order to build an entire application, you also depend on a lot of other services. So we have serverless data and storage systems, PaaS systems for databases and storage, messaging for queues and buses and topics and all the sorts of familiar things for sending information around, as well as a bunch of cognitive services for doing things like sentiment analysis or image recognition. And we have a chatbot service. And finally, with our focus on developers at Microsoft, unsurprisingly, we have a lot of IDE support, Visual Studio and Visual Studio Code, which runs on Mac and Linux as well as Windows. And you can do local development and debugging. And you can also debug remotely in the cloud with Azure Functions. So enough slideware. Let me welcome my colleague Yohai Kiriati onto stage to talk about Azure Functions. Hey, Yohai.
Hello, John. How you doing? Thank you very much.
Great.
Works? All right. Cool.
And I'm just going to lurk here and heckle you.
It's funny because I can't move from the podium, but we'll figure it out. As John said, basically, Azure Function is one of two serverless compute options that you have on Azure. And as you would expect, Azure Functions, basically you have code, and your code reacts to events, right? So as pretty evidently from our logo, which was created by a PM a day and a marketer at night, Chris Anderson, who later in the keynote will come up and show some of the cool demos we have around tooling. All right, so as we say, functions, you write code. And in this example, you see a JavaScript function. And one of the core principles we have in Azure Function specifically is we want to make developers successful very quickly. So we want to make things easier for them. And as John mentioned, some of those things, or a very cool feature is Azure Bindings. And bindings, to begin with, before the declarative, bindings are basically an abstraction of different services. So you can think of, you have different services, you're abstracted of how they actually interact with them, and you can just use that in your function. Bindings are also declarative, as you can see here, and it's pretty cool because declarative gives a lot of power. For example, if you look at the connection, as mentioned here, basically the Azure Web Job storage is an environment variable. So you can bring any connection string you want. Think about how easy it is now to deploy multiple different environments, how this fits into your DevOps and all of that. But the connection string abstraction of being declarative at that point is just one of the nuances around that. More interestingly, with Azure Bindings, basically you can create or you can define input and output parameters to your function as you would expect when you just write regular code, because basically we are writing functions. So in this example, what we got here is, for example, my queue item, which is basically a trigger input. It's an input binding as well as a trigger of a queue. So when anyone wants, whenever there is a new item on output queue, in this example, this function will be invoked, and we will pass the object, the actual data on my queue item. As you can see, you can just use that item directly in your code. Similarly, we have the my output blob, which references a blob. So you can write to the blob, and you can see over here how easy it is basically just to write to the blob pretty easily. You can either write to in JavaScript, you can either write to the binding, which is an object hang of context, or you can write directly to a parameter if you define it like here. And there are a few cool other things that you can do with bindings. For example, this squiggly Rand GUID will automatically generate random GUIDs for you that you can append, and you can use them as, for this example, the file, the name of the file. But you can also do other bindings to objects, like the ID of the queue and stuff like that. So bindings are wonderful. They're pretty powerful. Not enough to talk over a keynote, but they're pretty awesome. All right. So I think we've seen enough slides for this morning, right? So nothing like live demoing stuff and see how thing works with the Wi-Fi. All right. So this is the Azure portal. I pre-created an Azure Function app, and let's see if Wi-Fi works for us. Okay, seems to be okay.
Good start.
Let's see. All right, it is. So basically, this is the Azure function. This is the Azure portal. We're specifically in the Azure functions, and as you can see, I have an Azure function. Doesn't have any functions as of yet. Creating is pretty simple. It takes about a minute, so we can skip on that for the function app. Anyway, go back. Functions. So we can create a function. You can see I have some templates here. You can choose different languages. You can connect to a source control, but we will just go with some custom stuff. So Azure Functions support a variety of languages, as you can see here. Let's go with JavaScript for the audience. And we'll go with HTTP. And HTTP trigger, and all right, Wi-Fi, or not. This, we actually brought our own hotspot just to make sure we are okay with the Wi-Fi.
Somebody make a sacrifice to the Wi-Fi gods.
Yeah. Let's try again.
If this doesn't work, I'm going to have to start singing to entertain people.
Should work.
I can clear this theater so fast. They'd be like, was there a fire?
What's this? Okay, let's do this. Oh. Really? All right. So let's do no internet. Nice. Let's try to connect them to the regular conference and see how it works. If not, this part of the demo is going to be really short.
Yeah.
Yeah, whatever. Okay. Yay! I'm not sure why this is like, this one was special.
Yeah.
Failed us.
This was our backup plan. This was going to all work because, you know, conference Wi-Fi.
Yeah. Well, apologies for the conference Wi-Fi is working now. Okay, let's try to do it again. Let's recover from this, from source control. What the heck is this? No. Sorry. Custom function, my bad. JavaScript, HTTP, go with all the defaults, really quick, create. You guys can see the fonts? Yeah, looks good. Okay, so here it is. We have a function ready. And yay, all right. And basically all it takes is to create a function, and that's it. The function is live and working. All right, that was the demo. Thank you very much. Where are we? We're here. Okay. So yeah, this is basically all it takes. You have an endpoint you can work. This function basically is expecting some parameters, so we can basically go ahead of a name, and we can say serverlessconf Austin. And here it is. And just as easy, we can go ahead and make some changes. Welcome, right? Sounds good? Welcome to. Hit the save, go ahead, refresh, and voila. So this works, that's pretty cool. Okay, so one of the things I talked to you about is the bindings. And if we go to the integrate tab, you'll see here basically we have triggers, input and outputs. And I'm gonna just go ahead and create a new output trigger. As you can see, we have a bunch of supported services that we have. A bunch of Azure services, for example, Azure Storage Queue, which we're gonna pick. But you can see if I scroll, there are more and more. And there are also some external third-party partners like SendGrid and Twilio, which also have bindings, and the same concept apply to those. So we go with an Azure Storage Queue. We'll hit a select. We'll copy this because we need to, remember. So basically, this is our parameters we're going to use, queue name. We're going to hit the save button. Over here on the on the portal, we have documentation. We try to help in terms of explaining the concept, code example, and so forth, how actually to use this thing. So we're going to keep it very simple to recover from time and Wi-Fi. Basically, to work and to write, all I need to do is type context and bindings and basically the output name. And at this point, I can just pass any string that I want. It doesn't really matter. But what I want to show you guys is basically a little bit more of that. Not really a lot more, but I'm just going to keep it here just to be safe. Rec query name. Right, John? Didn't make no spelling mistake?
Nope, that's good.
Cool. And basically what happens here, we're just going to paste this object. So we're going to hit the save again. Going to go here and refresh, and that's it. I started pushing, pumping items into storage queue. We're going to add a few more items, and obviously we're going to add the canonical 42 examples. And okay, so we have some items in queue. What do we do with that? We're going to add another function. And again, we'll go with JavaScript. And where's the queue trigger? Queue trigger functions. And all we need to do basically is just give the queue name. As you can see, I've been given this demo for more than once. Hit the create. And basically, that's it. I have a queue function item. It's already running, because if I look at the logs real quick, you can see that it's already picked up like Austin and a bunch of other stuff, and probably 42 as well. And that's it. That's all it takes basically to create an HTTP endpoint, pump messages into queue, and from there you're off to the races.
That's good.
All right, this is pretty much it. All right, so after me, let's invite Jeff to talk about logic apps. Thanks, John.
Yep, thanks for having me.
All right, I get to test my luck now with the Wi-Fi gods, so let's see what happens. So I'm Jeff Holland. I'm on the Azure team as well, but I work on a service called Logic Apps. So while many of you here hopefully have heard of Azure Functions before, it's very possible that you aren't as familiar with Azure Logic Apps, which John introduced as that workflow orchestration engine in the cloud that is also serverless. So here I'm showing now, this is an example of an Azure Logic App. So it is a serverless workflow in the cloud. It's event-driven, there's no servers, it's consumption, micro-billing, pricing. But what's great about this is that now, you're writing these serverless solutions. Oftentimes, you have these little bits of code that do some great things, but you need to orchestrate them together. And often, more importantly, too, you also need to connect to other systems or services. You want to process data that's coming from some source that may not have a direct binding or an easy access point. So Logic Apps provides this visual designer for you to set up those triggers and actions. You can see here on this designer, whenever someone uploads the CSV file into an FTP server, that's firing off the serverless app, calling a few Azure functions, putting some stuff into storage, sending an email with Gmail. I think you get the idea. So this is very powerful orchestration for you to process your serverless apps together, whether you're orchestrating functions or other APIs, really any accessible web endpoint. What really makes Logic Apps great, though, is the number of out-of-the-box connectors that are provided. So I think I have on this next slide, this is you got to squint really hard to read all of this. I'm not expecting anyone to. But this is a list, it's probably out of date as of this morning, of the number of out-of-the-box connectors that are provided. John mentioned it ranges from Google Docs, Google Drive, to Office 365, all the way to things like an on-premises file system. So you can trigger a serverless application when you drop a file in a folder on your machine. So like on this laptop, I could drop a text file, which would go fire off this Logic app, could go process it with some Azure functions, and stick it into Slack or whatever I want to do with it. So this really, again, with our purpose here in Microsoft Azure, we want to enable and empower developers to be able to do and accomplish more. And we feel that Logic Apps is a very important piece in that, to say, hey, I need to go pull some data from Salesforce. I'm much faster to just say, go talk to Salesforce, instead of going and figure out, well, how do I authenticate with Salesforce? What do I do to get an access token? That's all taken care of seamlessly for you with the service. So this is kind of just a visualization of what a Logic app may look like. You'll see here you can orchestrate things on the right-hand side of the slide, which could be a SQL database, maybe Office 365, DocuSign. But the part that really gets me excited, that I see a lot of developers take their serverless apps to the next level, is actually the stuff on the left side, which is the other offerings available to you in the cloud. Things like cognitive services to do artificial intelligence and machine learning. Injecting that into your applications is very powerful, and I'm going to show you that in just a second. And again, we also provide access via an on-premises data gateway. So I know, you're like, serverless, what are we doing talking about on-premises data? But it's very possible that there is some data on-premises somewhere that you want to be able to process in a serverless fashion, and the tools are there for you if that's what you want to do. So that's enough talk. Let's see this in action now. Let's come over here to our wonderful desktop world that Yohai has set up for us. And here I have now on my screen, let me make sure that we're good with Wi-Fi. This is the Azure portal again, and now we're looking at the Azure Logic Apps Designer. Now this is a visual designer. You can build and orchestrate your serverless apps without having to write the code, but we do expect that there is some code you're going to want to have as a part of these workflows, and that's where the pairings with Azure Functions comes in great handy. So what I actually want to do is I want to build something a little bit fun here. I've noticed as we've gone throughout the morning that there's been a lot of tweets happening around Serverless Conference. So I actually want to connect to a data source, in this case Twitter, and I'm going to process all of the tweets that are happening with the word serverless in it. Now, don't tweet until I save this thing, but if you tweet after I click save, you'll be able to see those tweets get processed in real time. But before I even do that, I know I showed that beautiful slide before with all those things. It is just worth calling out again here. These are the number of services. You hopefully will recognize many of these icons that you can just connect your serverless apps to very easily. And there's some great stuff here like computer vision API to look at an image and detect what's in the image, emotions of faces, speech detection. We have Oracle here. Whatever you need to talk to, there's a good chance there's a connector. So in this case, we will say, I want to trigger this workflow whenever a new tweet is posted. So I'm going to go ahead here and say that's the trigger that I want to use, and now it just wants to know my search term, and I'll just say serverless. And in this case, I do have to check Twitter on some interval because they don't have some webhook mechanism just yet. So in this case, now I'm going to fire this thing off whenever a new tweet is posted. And now I want to start processing it. And I've written a few Azure functions that I'll call into in just a moment. You'll notice I can start adding functions in as steps. But before I do that, I do want to inject some intelligence into this workflow. So I'm actually going to add here one of the Azure Cognitive Services, which are these little bite-sized APIs that anyone can access to do all of the things that power like our bots or Cortana or all of the machine learning stuff. You'll notice here with like text analytics, I can do things like detect the sentiment of the tweet. And very easily, I haven't had to write any code yet. I haven't had to go and figure out how to authenticate or use these APIs. I'm now just saying, hey, what's the text that I want to analyze with this service? And I can pass in data from my other calls as well. So I want to grab the tweet text, whatever someone's tweeting about serverless. I want to detect it with some sentiment analysis. Maybe I want to do one other thing where I'm going to pull out the key phrases. So that hopefully gives you an idea of how fast you can start connecting to these different services. Now, I do want to run some of my own code as well. Maybe based on the score, I want to do some custom mapping or configuration of the tweet. So I'm actually going to add a parallel step here, and I'm going to call an Azure function. And what's fantastic is now I have some custom code running. I won't open it for you, but it's very simple. So how the cognitive service text analytics service works is there's a score between 0 and 1. 1 is like the most positive tweet in the world. If somebody tweeted something like, wow, Jeff is such an incredible presenter, this is such an inspiring presentation, that would get pretty close to a 1. If you tweeted something like a 0, like all the other presentations are terrible compared to Jeff, I actually don't know. Is that positive, or you'll have to test that one out. But anyway, that would get close to a 0, okay?
Can you delete tweets you don't like?
Have like the tweets coming in, I just remove them automatically. We'll see. Let's find out. No, unfortunately not. But what's great here is that I actually, when I clicked, I want to add an Azure function, this looks at my subscription. It knows the functions that I've written or I have access to. And it's actually created almost like this library of functions across all of the Azure regions that I might be deploying functions in. And I can call these as a step within any of these workflows. So I have this function which sets the score tier, so it kind of categorizes it as this red, yellow, or green based on the score. And I say, yeah, that's the one I want to call. And what's the content I want to pass in? Let's pass in that score from cognitive services. And just to kind of wrap things up, we'll come over here to this parallel branch, and we'll add a function that pulls out some of the key phrases and can do some stuff with the key phrases for us. So let me type that in quickly here. Serverlessconf, let's get those key phrases. In this case, I'll pass in a JSON object with some key phrases. Oh, there we go. Now, for the grand finale, because we do want to be able to visualize this somehow, I do want to publish this into some form so that we can see the tweets that are happening. So one of the connectors that we have out of the box is actually for Microsoft Power BI, which enables you to do these visual dashboards for any data source. So I'm actually going to take all this tweet data and I want to publish it to a real-time dashboard so we can see these tweets in real time. Again, just one other thing I'll show you in terms of we want to make it very simple for any developer to build these serverless orchestrations and connect them with services. You'll notice here that because I've authenticated with my account, hopefully this one works, it's actually looking at my Power BI subscription, and it knows the different data sets that I have available. It knows the different tables that are available. So I haven't had to go and pull out like the GUIDs, that's the actual integration code here. I just say, hey, I want to push to this serverless live dashboard. And the designer's automatically gone, and you'll notice it's actually listing for me right now. Here's the different columns that are available in this table for me. So it's just so easy for me to stream all of this data from my different sources and my function apps into very powerful end-to-end solutions. So let's grab what the tweet is, who's tweeting it, where they're tweeting from, when they created it, what their score was on how positive or negative the tweet was. Let's get the key phrases from that key phrases function, and let's get the category from that score tier. Okay, that's it. So I'm going to go ahead and click Save here, and I'm done.
Start tweeting.
Yeah, yeah. There you go. It's running now. So I'll actually go ahead, and this is now listening to Twitter for all those tweets. This is one that's been running all day. So this is the Serverlessconf tweets. You'll notice actually you can see in this dashboard, this is right when the keynote started. This was during the breakfast while you guys were all eating and not as much tweets. But you can see very, very strongly on this when the keynote started. You can see the different tweets as they're coming in. You can see the sentiment scores. If I come over to this one that we just published, if you guys are tweeting, there we go. So we're starting to see some stuff come in. Too negative? What is this? What are these negative tweets? So I can actually see, there we go, there's a 1. So who's this 0.98? Here, let's give the plug to SKIR, whatever, Skrikar. This person is the best because they're writing about great job, Logic App, Serverlessconf. Thank you, okay? Anyway, but even, so you watched me build that from scratch. Obviously, there were about 40 lines of Azure functions I didn't show you. But hopefully you get the idea of just how quickly you can build these end-to-end applications and connect them to the data sources that you care about. So with that, that's an introduction with Logic Apps. We'll be showing more today. If you have questions, I'm here for the week, so come visit us at the booth. But now I actually want to pass it over to Chris Anderson, who's going to come show some end-to-end functions.
Developer
experiences that you can have. So with that, Chris.
Thanks, Jeff. So we've seen the two primary platform pieces I talked about, Azure Functions and Azure Logic Apps, and we've seen them using together. And so let's talk about the developer experience.
Right. So I'll stand closer. I like to move around. I'll have to be careful. So just a quick show of hands here. As great as the writing a bunch of code in the portal thing is, how much of you guys actually use the portal to write most of your code versus wanting to use CLI? CLI, okay, yeah, that's what I was looking for. So here I have a function app, and I could go ahead and show pretty much the exact same demo as Yohai, but what I wanted to show off was a lot of the investments we've been making in tooling for Azure Functions that works primarily from a CLI type experience. So rather than go ahead and move through my demo inside of the portal, let's go ahead and jump out to just a command window. And what I've got here essentially is just an empty directory. There's nothing inside of here, and what I want to do is go create a few functions and deploy them up to Azure and show local debugging as well, all without having to leave the command line at all. So I'm going to go ahead and do func-init, and this will go ahead and create a new project for us. So this sets up all the various things that the project expects to see when I go ahead and do that. I can then go ahead and do func new, and then we have this nifty little experience where I can choose a function. In this case, I'll choose JavaScript. We have a bunch of different templates inside of here, but I'm going to go with HTTP trigger for something simple and give it a meaningful name like HTTP.js. Just a very simple demo. And I can, of course, go ahead and view this inside of, for instance, Visual Studio Code. And go ahead and close this one because I don't need that. And inside of here, I can see my function is now in this directory. And the nice thing is that functions have this concept of having a collection of functions. So I can go ahead and deploy many functions to the same app without having to provision new resources. So I can go ahead and do the exact same thing here, but just create another function. We can see them both running side by side. So I'll go ahead and do this, and just to keep things nice and simple, we're going to go with HTTP trigger again, but I'm going to give this one an even more meaningful name, foobar. So once I do that, I can see this. I've now got both of these things in just 2 separate directories. Each one of these things contains their function.json, which is the configuration for how your function runs. This means that I don't need to run a bunch of management commands after I've deployed the code out there to actually go and configure how the trigger will work. It's just going to use this JSON that's inside of here to go ahead and decide what it's going to listen on. And in the case of functions, as Yohai showed before, if we have any output bindings, you can also configure any output bindings you have right here inside of configuration. So it doesn't require any additional management calls to make. So inside of here, I have my code, and the really nice thing is that I can then do something like func host start. And this will actually go ahead and start up a local instance of Azure Functions running just on my machine right here in the command window. So I can go ahead and do that, and then I can do something like just going to localhost 7071. You can see there's a bunch of other random ones, but I created HTTP JS. And I get my super awesome, meaningful demo there of, hello, please pass a name on the query string and the request body. And I can go ahead and do name equals world. So now we've done hello world from the command line. The nice thing here is that we didn't lose that kind of interactive experience that we get when we're working in the portal where we make updates and on the fly it updates things. So I can go through here and do the normal thing of just, let's go ahead and add some exclamation marks, get super excited about this, refresh this window, and automatically our host picked up those changes and is now serving those that new code that we wrote. So it's that same kind of fast experience that we got in the portal now works locally using the tools that I want to go use. I mean, this is using VS Code here, obviously. If I was doing something, more intelligent, VS Code can actually understand what various pieces are when I'm coding, so I can get full IntelliSense when I'm working inside of VS Code. I can add typings and things along those lines, and it'll work. We'll get that kind of experience. But it's not enough to just go ahead and be able to edit code in VS Code. We also want to be able to go ahead and debug code in VS Code. So let's take the same function we have, add just a simple breakpoint there, and instead of doing func host start, I'm going to do func run with a specific one and do --debug. And what this will do is it'll drop a launch.json for us, and we should now be able to see that there in the .vs code file. I can click on our little debugging thing, and you see this attached to Azure Functions setting. I can now click on this, and now it will connect, and we're now going to be attached, and this breakpoint should run when I go back to the command line and hit enter. So if I go here, and I hit off the screen now. There we go. If I hit enter now, it'll run, and debugging gods. There we go, that one connected. Do the same thing again, but I don't need to do --debug the second time I run it once I've connected. And you see here that we've actually hit the breakpoint. I can see what was passed on the request. I can see the full object here. I can actually change this. So in this case, I didn't pass anything on the query string, but let's say that I really wanted to pass something on the query string. I go through here and modify this object so it was actually name and world. Enter there, and go ahead and click on continue. And we should actually see our response we get there is the hello world response, when we would have previously gotten that, please pass the name on the query string and request body. So we get that full, really awesome Node.js debugging experience inside of VS Code without having to do anything else except for setting that --debug flag to give us our launch.json configuration. So now I can debug locally, see all those things, and really what you'd expect as a Node.js developer today for developing code. So now that I've got that stuff running, and that's all well and good, the next big thing there is, of course, that I do want it eventually running on Azure. So, like I said, I have this function app right here. I'm just going to copy this to make sure that I get the name exactly right. And the nice thing is this same functions CLI that we have here has the ability to publish straight to Azure. So I can go ahead and do func Azure function app publish, and then just give it the name. And I've already signed in. Normally it would just ask me to sign in with my Azure account. It'll go ahead and open up a window and I'll just sign in like I normally would. I don't need to go ahead and like copy in some like, admin connection environment variable or anything like that. It'll just use a token that it's saved locally on my machine. You can see in this case what it's doing is it's just going to go ahead and grab the publishing info for us from Azure. It's going to go ahead and create an archive locally for us. So it's just going to create the zip and then upload that zip for us without having to do any of that hard work ourselves. Just press the button and watch it run, and off it'll go. So now that it says that it's completed successfully, I can go back to my portal, click on the refresh button, and we should see now that we have our 2 functions here, and it even has our fancy little exclamation mark changes that we had. So all that, I was able to go ahead and create 2 new functions, test them locally, make some small changes, and publish them to Azure, all in the span of like, what, 5 minutes? Something like that?
6 minutes.
6 minutes. Yeah, so that was a really pretty fast experience there with me talking over things rather than just going at this. And when I'm not talking and trying to explain myself as I go, I can go ahead and set functions up there in 2 minutes, less than that really. So now that I have my functions in the portal, and presumably they're doing something more interesting than just hello world, what I really want to be thinking about is how do I then monitor those functions? And we actually have this new experience that we actually released into public beta a month ago or something like that, which is Application Insights integration with Azure Functions. And the cool thing about this is I can have Azure Functions that are running at various levels of scale and things along those lines, and I can actually see really, really deep, rich telemetry about them. These are not just trace logs or anything along those lines. I can actually see per request, performance telemetry, dependency information, anything you can think of that you'd want to actually go ahead and track as far in terms of metrics about your function now comes out of the box as something that's available for you to use. And so you can kind of see an example of that here. I have this function here, which is actually just reading messages off of a queue, and then it's checking the max generation on that queue, seeing if it's 0 or not, and if it's not 0, it re-enqueues itself on its same queue. So this thing is essentially going to run n number of times, and this allows me to go ahead and generate a lot of load really quickly by essentially just doing exponential kind of load creation. The nice thing about this is this thing's not, if you look at the code here, none of this code is doing anything to emit telemetry. There's no extra shims that I've added inside of here. This is just normal Azure Functions code, all of 5 lines of it. It's not doing anything interesting. The only thing really interesting here is this context log statement, which you would normally have. This is normally your trace. And we'll be able to see this same trace show up inside of Application Insights in just a sec. So the Application Insights that I have set up for this particular case is this one here. And Application Insights is actually something that's been used on Azure for web projects for a long time, used with really any kind of application you were building before. And you could have used it with functions even before we did this integration, but now we've done it so that there's literally no code that I have to add, and I get 60% of the features that light up automatically. And so in this case, you can see here that automatically I have this awesome dashboard that if I close my Essentials thing, I have an alert that fired. I had set up a custom alert, and this thing is actually able to go through there and then call a webhook or some other command to go and then trigger some automation workflow. I'm not going to go into it in this particular demo, but this is actually calling a logic app which is connected to an email service for me, and it's sending me an email basically custom specialized for what that alert was. The other really awesome feature that we have is this live stream view. And what this does is for every instance that our application is running on, it'll actually go ahead and send us real live information coming from that server. We know that we call this stuff serverless, but the truth is there are actually servers behind the scenes. And for a long time, we've always gotten questions of like, oh, how can I actually figure out what was going on the machines that I am running on? And Application Insights actually just solved this problem for us without a whole lot of work from our side, really. We just go ahead and wrapped it deep into kind of our execution pipeline. And now I can actually see the server name that I'm running on underneath the covers. And if I were to go ahead and trigger, a big scale-out workload right now, you could actually see us go ahead and scale out to, dozens of instances all in the matter of seconds. And I can actually see the requests failed and stuff like that per instance. So, as we keep on using that warm machine over and over again for each of your requests, you can see whether or not, well, maybe I have a memory leak. I can see one of those instances, their memory usage is climbing up over time. I probably want to go ahead and look to see whether or not there's something wrong going on inside of my code where I am leaking that kind of information. So you really can get a lot of insights, and this is all live. So one really cool thing that I can do here is if I go ahead and just open up another portal here, and I'm just going to, this is the thing that Yohai warned me about, that I've got to go ahead and drag this off to my, my garbage screen. And then inside of this thing, I'm just going to open up that functions window again. And one really awesome thing is, let's say that you're running under load, you've got some customers telling you that there's something going wrong inside of your application, and you just kind of want to see that in a visual sense. Well, I've got this function here that is aptly named born to fail, and all it contains is this throw new exception boom message. So it's never going to do anything except for fail when I run it. And that's
Useful.
It's very useful because what I really want to do here is show off that as soon as I click that, within a second, I actually go ahead and get the full trace information there about what particular thing was going on. I can go click on the actual exception message itself. I can see that full exception message, and if this was a more rich exception that had more information, we'd see that full text here. In this case, I just see boom. And I can see the instance name it was on, so if I was looking for a bad instance that was doing some bad things to me, I could correlate that. And then I also get the full nasty stack trace that most people don't want to actually read through unless they've been forced to do so. All in kind of a live view. So I don't have to go ahead and wait for that to actually make it through a telemetry pipeline and someone to report it to me. I can actually go ahead and see, oh, this error is being thrown a lot. Let me go ahead and just click on that and start diving into it without having to go and investigate, well, what might it be? I can actually see it live, what's particularly happening. But that's just the start of where Application Insights ends up being really useful with functions. One other cool thing is that I can actually go through there and just see overall views for all these things. So if I wanted to look back over the last day or so, how were my servers behaving, you can see here that I had this big spike of activity that happened earlier today, basically, when I went and ran a big load test. And I can go ahead and look at how the individual servers themselves were behaving. You can see that in this case we were running on
Lots.
probably like 12.5 servers just for that particular case for the last 24 hours. And you can actually see yourself move on and off servers. So you'll see us load balance you to new machines as we go through there and kind of acquire new machines. And so you can even see weird things. I know that sometimes people try to go in to detect when they get swapped machines because there's cold start or something like that they detect. You can actually see whether or not we're doing that to you based off of just this particular view. For the most part, we don't. We try to keep you on the same machines all the time. But if for instance, you did get moved and you saw a spike in latency, you could correlate that to, oh, I was on a new machine. That's the reason that happened, without you having to go through there and instrument all of your stuff yourself and try to reverse engineer how we're working. We'll just tell you automatically. So the next big piece that we have then is, of course, going to be the analytics features. And this is going to be kind of this is where you're going to spend a lot of your time once you're using Application Insights, beyond just the kind of okay, what's happening right now. This is where I then go and look, why did that thing happen? And so for that particular piece, we can go into App Insights, and this has just a really, really rich programming model. I can't show nearly all the features that this thing has. I'll show more in some future demos. But I can go ahead and look for all the requests where a particular thing happened. I can summarize those requests. Let's say I want to go and look at all of my various percentiles for latency. I go ahead and do percentiles. Go ahead and do 50, 95, 99. And then what I want to do here first is, of course, I want to do summarize duration by 50, 95, and 99 percentiles. And I'm going to do this by buckets of time of my timestamp. And I'm going to do this in 1 hour buckets. And go run this, and this will look over the last 24 hours automatically. I can change that with this little knob here. And then the nice thing is I have this table, but I really want to see it as a graph. And so now you can go ahead and see, let's go ahead and use a line. That's a little bit nicer. I can now see inside of here what was my average latency, what was my 95th, and what was my really outlier cases for latency. And you see this really cool purple dot. I can actually click on this, and we'll run automatically regressive analysis on that telemetry to go look for what was the interesting stat there. And in this case, it found that there was a bad instance that caused this to have really long latency. Cool. So the final piece of this particular demo, it's a kind of an announcement of sorts, is we actually added TypeScript integration, and that's rolling out right now. It's in WestUS 2.
That's nice. Got some TypeScript fans?
And so normally you could have always gone ahead and had a build process locally and just you would build your TypeScript and then go ahead and deploy your JS file after it had been transpiled. But we really like TypeScript and it's nice to work with. And right now the portal doesn't have all the improvements we'll have, but we'll actually have full TypeScript IntelliSense and loading of types and all that kind of stuff in the portal. So you'll get that full TypeScript experience in the portal as well as locally. And you can see here that I'm actually using nice advanced features like the async feature inside of TypeScript. So I can go ahead, instead of having to chain my promises all together, I'm actually able to just go ahead and do await and things along those lines with my functions. And it's all supported right out of the box. I don't have to do anything. If I save this, what you'll actually see is that we'll go ahead and run the transpilation step. And then in your files output here, you'll see the output, and you can actually see what the transpile.js is right here in the portal. So you don't have to figure out what that mystery was either. You can just see what we came up with. So
very cool.
With that, thanks, John.
Yeah, thanks for coming out. Okay, so thanks for everybody. So that I'm almost done here. That kind of leads me into the next thing. Not used to his trackpad. We just talked about this. So I saw, how many people are TypeScript fans? I saw quite a few applause for that. Oh, good. So this leads into, naturally, a subject very near and dear to my heart, which is open source. Many of you may know Anders Hallsberg as the creator of C#, or before that, Turbo Pascal. TypeScript is Anders' latest project. What you may not know is that the entire TypeScript project has been developed on GitHub pretty much from the beginning. And Anders is the #1 contributor to that project and very active at all times. We contribute at Microsoft to a lot of different open source projects. So another one is Docker, which you probably all heard of. Did you know that a gentleman named John Howard from the Microsoft Windows team is actually the #4 contributor all time to the Docker project and the largest contributor for the last year? Chris was showing Visual Studio Code. Visual Studio Code is another project that lives and is developed entirely in open source on GitHub. So you can go in and add features and monitor pull requests. It's a very active and exciting project. But this is just a kind of a touch of all the open source work that's going on inside of Microsoft. We have literally thousands of employees, thousands of open source projects that we do ourselves and contribute to. Briefly, I want to just talk about Azure, because Azure is also a cloud that runs everything that developers want to run, from DevOps tools like Chef and Ansible, down through different types of applications, app frameworks, databases, and infrastructure and operating systems. As part of my developer job, you may be surprised to find out that I am Microsoft's representative to the Linux Foundation Board. Now, the history of .NET is is actually quite a long open source history. .NET in 2002 was actually released as open source. This was before GitHub, so it came as a big tarball, and you just basically could get the code in that way and work for BSD. More recently, we've gone legit and gone into GitHub, and most of ASP.NET has been open source for about 8 years. And why I brought this up is that Azure Functions, a lot of the underlying technology was originally built as part of Azure websites, and it's been an open source basically from the beginning. So you can go and find the runtimes, even the portal, the CLI on GitHub, contribute fixes, dig into the code to understand how it works, all the advantages of open source. And so that's pretty much our presentation. I do want to say, if you want to see more about Azure Functions, Don and Chris have a session later about developing for Azure Functions. We have a couple of hopefully happy, Azure customers that are coming in. Michael Corning's going to come in and talk about how they revolutionized their development process, going from traditional PaaS and IaaS systems to using functions, and we're able to get much faster activity. Tomorrow, Yohai is a talk about serverless design patterns. And then we have another customer, Richard Senior from Plexure, who's done some really interesting stuff for their customers, where they reuse parts of functions and logic apps to build so that customers have an app development experience. And so that's pretty much it. We wanted to give you an idea of Azure Functions, Azure Logic Apps, how these things connect, the developer experiences around them, and we invite you to go and try. These try links are completely free. There's nothing to sign up for. You just go in and you can start playing around with functions immediately, and of course you can also go to a GitHub and learn about the code. Thank you very much.